Hello students, welcome back. This is your professor Dr. Hina Sheikh back with you again to not to explain basics this time but to go little advanced. This video is for advanced learners and obviously not for basic learners, where I'm going to talk about the food and the cosmetic industries. We are going to learn about food processing, preservation, then the chemical methods of preservation, the physical methods of preservation. We are going to talk about the role of pH in the preservation. Then we'll learn very common preservatives like the boric acid and sodium benzoate. We are going to study the analysis of food products like milk, honey. Then we have tea, coffee. After this, we are going to study more about cosmetics. So we'll study in details about face powder, lipstick, deodorants and aspirins and few more things. So without wasting time, let me quickly start with food and cosmetic industries. Processing and preservation. Now, now I'm going to start with the lecture and I'm going to talk about the food preservation and processing. So before I start, we all know about what is food. Food is the material which we eat, which quenches our hunger. So what is the difference between food and a medicine? Medicine is not a food, correct? And food is not a medicine. Medicine is something which we take in a very small quantity and food is something we take in a large quantity. Another thing everybody should know is food should be taken properly. If you take food properly, then you do not require medicine at all. So now we are going to start with food processing and preservation. Food generally undergo deterioration or spoilage from time they are harvested or manufactured. Deterioration of food can be due to microorganisms like bacteria, yeast, and molds. Activities of enzymes present in food, insects, parasites, and rodents, temperature, moisture, oxygen, light, and time. The underlying principle of all preservation techniques is to restrict food spoilage so that food can be used safely in palatable form at a later time. Preservation methods are designed to inhibit the growth of organisms, the removal of organisms, and killing the organisms. Food preservation should also arrest biochemical breakdown of tissues and the transformation of its cell contents. This is achieved by heat, cold, drying, fermentation, radiation, and chemicals. Preservatives are ordinarily defined as substances which have antiseptic properties under the conditions of use, that is, they are substances which inhibit growth of microorganisms without necessarily destroying them. Effective inhibition of microbial growth prevents spoilage of foods. The compounds used as preservatives include natural preservatives such as sugar, salt, acids, etc., as well as synthetic preservatives. Chemical preservatives provide one of the most effective defenses against microbial activity in foods. Chemical preservation may be classified as inorganic preservatives, organic preservatives, and sweeteners. Inorganic preservatives include examples like nitrates, nitrites, sulfates, sulfurous acid, borates, iodates, free chlorine hypochlorites, peroxides. Organic preservatives include examples like benzoates, formaldehyde, salicylates, formic acid, esters of para-hydroxybenzoic acid, propionic acid, thiourea. Then sweeteners include saccharin and dulcin. Now I am going to talk about commonly used preservatives. The first preservative which is commonly used is NaCl or sodium chloride. It has been used as food preservative from early times. Salt stops the growth of microorganisms and interferes with the action of proteolytic enzymes. Salt also caused food dehydration by drawing out water from the tissue cells. Salt is employed to control microbial population in foods such as cheese, butter, cabbage, cucumbers, fish, bread, etc. The second type of preservatives which we know is sugar. The high osmotic pressure of sugar creates conditions that are unfavorable for the growth and reproduction of most species of bacteria, yeast, and molds. Sugar is used in syrups, confectionery products, honey, jams, jellies, fruits such as dates. The next thing which we are going to study is sulfur dioxide SO2. It is used in the treatment of fruits and vegetables before and after dehydration to extend their storage life. It is also the most useful agent for the prevention of browning reactions in dried fruits. Most cut fruits are treated with sulfur dioxide to prevent enzymatic browning. So the browning of the fruit which happens, especially apple, when you cut and keep it, it becomes brown because of oxidation. So you treat it with sulfur dioxide so that it doesn't become brown. Forms in which sulfur dioxide is employed as preservatives include the gas, so you can use gas like SO4, the sodium or potassium bisulfides like NaHSO3 or KHSO3, sulfides like Na2SO3 or K2SO3, and metabisulfide like Na2S2O5 or K2S2O5. The next thing which is used as a preservative is nitrate and nitrite. These are also known as curing agents and are used to preserve meats, give them desirable color and flavor, and to prevent toxin formation by stopping the growth of microorganisms. So one of the examples is sorbic acid. Sorbic acid and its sodium and potassium salts inhibit molds and yeast in food such as cheese, baked products, fruit juices, wines, and pickles. Next we know is acetic acid. Acetic acid in the form of vinegar has been used to preserve pickled vegetables from antiquity. Acetates of sodium, potassium, and calcium are used in breads and other baked goods to prevent growth of molds. Next, we are studying about propionic acid. Propionic acid and sodium and calcium salts exert antimicrobial activity against molds and some bacteria. The acid finds extensive use in the bakery field where it is not only inhibits molds effectively but is also active against the ropey bread organism Bacillus menceretis. Next we are going to study is about benzoic acid. It is widely used as an antimicrobial agent. Its sodium salt is more soluble in water than free acid and hence it is generally used. The acid is most active against yeast and bacteria and least active against molds. It inhibits optimum activity in the pH range of 2.5 to 4 and thus is well suited for use in acid foods such as fruit juices, carbonated beverages, and pickles. Next, we are going to learn is about parabens. These are alkyl esters of para-hydroxybenzoic acid. The methyl, ethyl, propyl, heptyl esters are generally used. These are effective inhibitors of molds and yeast but are relatively ineffective against bacteria. Next, let us see epoxides. These are cyclic ethers that destroy all forms of microorganisms, including spores and even viruses. Ethylene oxide and propylene oxide are commonly used epoxides in their gaseous form as preservative for nuts and spices. Then we know about antibiotics. These are antimicrobial agents produced naturally by a variety of microorganisms. Antibiotics are of great chemotherapeutic value in controlling pathogenic microorganisms in living animals. These include niacin, piperacin, chlorotetracycline, and tetramycin. These are used to control growth of spore-forming bacteria of dairy products, cheese, sausages, fish, and poultry. Next example is diethyl polycarbonate. Diethyl polycarbonate has got C double bond O bond, two C double bond O attached by a carbon, attached by oxygen, and both the sides you have OC2H5. So the structure is like this. We have O, C2H5, then we have C double bond O, again oxygen, again C double bond O, and then here I have O, C2H5. It is used as an antimicrobial food additive for fruit juices, wines, carbonated beverages. It acts as a cold sterilizing agent for aqueous conditions. Let us now see some chemical methods. First is use of chemicals in preservatives. Volatile fatty acids in bakery products. Fatty acids contains from 2 to 14 carbon atoms, particularly propionic, butyric, caproic, caprylic acids, etc. are effective mold inhibitors. Propionic acid and its salts are fairly widely used in bakery products for the preservation of ropiness and of mold growth. It is necessary at times to establish the concentration of mold inhibitor used. Fresh or air-dried bakery products is ground well and mixed with water till all lumps are completely broken. It is then treated with sulfuric acid followed by phosphotungstic acid. The mixture is then centrifuged and the centrifugate is refluxed with silver sulfite. The refluxed mixture is cooled, filtered and transferred to a distillation flask. The distillate is titrated with barium hydroxide. Next is benzoic acid in jams and jellies. Benzoic acid is usually used as a preservative in the form of calcium, sodium, or potassium salt. For the purpose of the regulations, the amount present is calculated as the acid itself. Benzoic acid retards the growth of yeast and molds. The extent of antimicrobial action is markedly affected by the pH of the medium, the action being optimum between pH 2.5 and 4 and diminished pH values above 5. Benzoic acid is determined by titrimetry or spectrophotometry after separation either by solvent extraction or by steam distillation. Benzoic acid is shaken out directly with ether or light petroleum after acidifying sample with dilute sulfuric acid and saturating with salt. The acid is purified by shaking the bulk ether extracts and with dilute sodium hydroxide and then treating the alkaline solution at 60 degrees Celsius with permanganate to remove interfering acids. The excess potassium permanganate is reduced with sulfur dioxide and the benzoic acid extracted with ether after acidifying the aqueous solution. The solvent is removed with gentle heating. The residue is dissolved in acetone and titrated with 0.05 molar NaOH. We know 1 molar is 0.05 1 ml of 0.05 molar NaOH corresponds to 0.0061 gram of benzoic acid. Very small amount of benzoic acid can be estimated in ethanol solution by measurement of the UV absorption spectrum. The next is acetic acid. In pickles, pickles often contain a mixture of chopped vegetables and thick sauce. Thick sauce usually consists of fruits, onions, sugar, vinegar, spices. According to the type of material, the sample is mixed in a pestle and mortar and blended mechanically. Total acidity is determined by stirring the sample with water and titrated against sodium hydroxide. Fixed acidity as acetic acid is determined by stirring the sample with water and evaporating water to dryness. This procedure is repeated and finally the residue is stirred up in water titrated against sodium hydroxide. Then percentage volatile acidity is calculated as volatile acidity is equal to total acidity minus fixed acidity. Percent total volatiles is equal to 100 minus total acidity. Percent volatile acid in the aqueous phase is equal to 100 multiplied by total acidity divided by total volatiles. In general, the volatile acid in the aqueous phase should be at least 3.5%. Next we have is lactic acid, which is used in poultry. Lactic acid is extracted with ether using liquid-liquid extractor and is subsequently estimated colorimetrically with ferric chloride. Sample is prepared in water which is treated with sulfuric acid and phosphotunsitic acid. The filtrate is then subjected for ether extraction so as to extract lactic acid. The extract obtained is treated with ferric chloride solution. After giving the acid treatment and the absorbance of the solution measured is noted. Standard curve is prepared by measuring the absorbance values for standard barium lactate solution. Next is sulfite, which is added in fruits. It is determined by using Kejadal's flask. Sample is taken in the flask with water and phosphoric acid. The flask is heated and the distillate is collected in an iodine solution kept in a beaker. Excess of iodine is boiled off and the solution is treated with hydrochloric acid to make it acidic. It is further treated with barium chloride to precipitate sulfides as barium sulfate. The precipitate is filtered, dried, and is ignited to ash in a platinum crucible. The weight of the residue obtained is due to barium sulfate obtained. Let us now see the role of pH in the preservation of food. Effect of pH is mainly observed in case of organic acids and their salts. Lactic, acetic, propionic, and citric acids and their salts may be added to or developed in foods during fermentation. Citric acid is used in syrups, drinks, jellies as a substitute for fruit flavors and for preservation. Lactic and acetic acids are added to brines of various kinds and green olives. Sodium propionate and calcium propionate are used most extensively for the preservation of mold growth and rope inhibition in bread and other baked goods, and for mold inhibition in many cheese products and spreads. They are effective against molds but have no inhibitory effect on most yeasts and bacteria. Their effectiveness decreases with an increase in pH, with an optimal upper limit being 5 to 6 pH depending on the food item. They are ideal preservatives for bread and baked goods because even after the destruction of molds by heat during baking, decontamination of bread can occur during slicing and wrapping. They can be added to the dough of yeast raised baked goods as do not inhibit yeast activity and leavening of bread. Let us now see some physical methods for food preservation. First is pasteurization. I'm sorry. The first method is pasteurization. Pasteurization derives its name from Louis Pasteur, who found that the heating of liquids, especially wines, to a high temperature improves their keeping qualities. The aim of pasteurization of milk is to get rid of any disease-producing bacteria that may contain and to reduce substantially the total bacterial count for improved keeping qualities. Pasteurization of milk destroys approximately 99% of all bacteria as well as most of the yeast and molds. Two methods are employed for pasteurization. In the batch process, two combinations, example 63 degrees Celsius for 30 minutes and 72 degrees Celsius for 15 seconds, are the ones most commonly followed for commercial pasteurization, and the corresponding process are called holder or batch or LTLT, which means low temperature long time method, and HTST, high temperature short time method. Ultra high temperature treatment at 93.4 degrees Celsius for 3 seconds or 149.5 degrees Celsius for 1 second is also employed. There are also methods for obtaining sterilized milks in containers. Pasteurization is a temperature time effect, which means process depends on the combination of these two parameters and not on either of them alone. The following are the criteria for selecting temperature time combination for pasteurization. First is the most heat resistant pathogen, Mycobacterium tuberculosis, now which is called as Coxiella burtonii, is considered in its place, should get killed so that the object of killing all pathogens can be achieved with the temperature time combination method. Second, the phosphatase test should be negative. In other words, phosphatase enzyme of milk should be inactivated with the temperature time combination used. The cream line, that is the line between the lipid and the aqueous layers, should be minimally reduced if at all with the temperature time combinations used. Since the most heat resistant pathogen is destroyed at a temperature slightly higher than the required for phosphatase inactivation, pasteurization may be carried out at a temperature above that for phosphatase inactivation and yet below that for cream line reduction. It is observed that the lower the temperature of exposure, the longer the time needed and vice versa. As pasteurized milk is not sterilized, it must be quickly cooled after pasteurization to prevent multiplication of surviving bacteria. The temperature and time used for pasteurization are not so high as to alter the constituents or properties of milk. Pasteurization does not produce an objectionable cooked flavor and no important change in nutritive value takes place, except for a slight decrease in the heat liable vitamins like thiamine and ascorbic acid. The shelf life of the milk is increased by pasteurization. The thoroughness of the pasteurization of milk is ascertained by testing for the alkaline phosphatase activity in milk. This enzyme has heat destruction characteristics that closely approximate the time temperature exposure for proper pasteurization. The enzyme liberates phenol from Phenyl phosphate. The liberated phenol gives a deep blue color with certain organic compounds. If the milk incubated with phenyl phosphate does not give blue color with the indicator, it means pasteurization is complete. The second method we are going to learn is irradiation. Radiation may be defined as the emission and propagation of energy through space or a medium. Radiation of wavelengths less than 200 nanometers, such as ultraviolet light, X-rays, gamma rays, alpha particles, beta particles, are called ionizing rays and are of importance in food preservation. These radiations have sufficient energy to ionize molecules in their path. They destroy microorganisms in foodstuff without raising the temperature, and hence irradiation process is termed as cold sterilization. Ionizing radiations penetrate the food to varying degrees depending on the nature of the food and the characteristics of radiations. Gamma radiations have greater penetrating power than the beta radiations, but the latter have greater ability to ionize molecules. When the ionizing radiations pass through foods, breaking of chemical bonds occur, resulting in the formation of ion pairs and free radicals. The reactions of these species with other molecules provide the mechanism of alteration of food constituents, enzymes, and microorganisms. Ionizing radiations destroy all types of microorganisms. Gram-negative bacteria are less resistant to radiation than gram-positive bacteria, and spore formers are more resistant than the non-spore former. Micrococcus radiodurans is one of the most radiant-resistant microorganisms. Food must be properly processed prior to irradiation. Foods for irradiations must be selected on the basis of their freshness and overall desirable quality. Food must be clean to make it free from dirt. Glass containers cannot be used as they undergo changes in irradiation. Let us now see the irradiation process. Gamma radiation from radioisotope of cobalt-60 or cesium-137 and electron beams from linear accelerators are commonly used for irradiation of food. The radiation doses depend on the nature of the food, the resistance of microorganisms, and the resistance of enzymes apart from the cost of the process. Several units are used to express the dosage of radiation. A Roentgen is the quantity of gamma radiation or X-ray radiation which produces one electrostatic unit of electric charge of either sign in a cubic centimeter of air under standard conditions. The most widely used unit of radiation dosage is the rad, which is equivalent to the absorption of 100 erg per gram of irradiated material. A megarad is 1 million rad. Rad means radiation. A gray is equal to 100 rads and a kilogray is 1000 gray. Radiation dosage required for most of the food has been established on the basis of the logic that the spores of C. botulinum are the most radiant species. The DM value refers to the radiation dose necessary to reduce the existing spore population by 90%, and in case of beef, it was estimated to be 0.4 mrad. A 12 dm value of radiation dosage provides complete sterilization of the food. The radiation treatment given to foods is of any one of the following types. The first type is Pasteurization. It is equivalent to radiation sterilization, equivalent to commercial sterility as practiced in canning industry, where the typical levels of radiations are 30 to 40 kGy. This method can be used to reduce nitrosamines in bacon containing sodium nitrite. Second is Eradication, uses 2.5 to 10 kGy and is equivalent to pasteurization of milk. It reduces a number of non-spore forming non-viral pathogens. The third one is Redurization, which may be considered equivalent to pasteurization. It enhances the keeping quality of foods by reducing number of spoilage microbes. The radiation dosage levels are in the range of 0.75 to 2.5 kgY for fresh meats, poultry, seafoods, fruits, vegetables, cereals, and grains. Next point is determination of boric acid as preservative. So let us see how do we determine boric acid as preservative. Determination of boric acid as preservative. So you have to find out if the food material is containing boric acid. Boric acid is determined by a volumetric method, but the results may have considerable errors if the foodstuff contains large proportion of fat or phosphates or small proportions of boric acid. To avoid the errors, boric acid is esterified with methyl alcohol. Methyl borate formed is distilled and titrated after the addition of mannitol. The acidified ash of the foodstuff is boiled with methyl alcohol in Kajal flask. The vapors are collected in sodium hydroxide solution containing mannitol and phenolphthalein indicator. And you know the equation, 1 ml of sodium hydroxide corresponds to 0.0031 gram of boric acid. Let us now see study and analysis of food products. The first food product which we are going to study is milk. Milk is one of the most important foods in human diet because it has many components present in very small quantities that are essential to growth and well-being composition of milk. Milk from different sources will contain same classes of constituents. They are milk fat, which is 3 to 6%, protein 3 to 4%, milk sugar 5%, ash 0.7%. Water accounts for the balance of 85.5 to 88.5%. All the solids in the milk are referred to as total solids, which is 11.4 to 14.5%, and the total solids without fat is known as milk solids no fat MSNF or solids not fat. So we can compare what is the amount of water, fat, protein, lactose, and ash present in buffalo milk, cow milk, goat milk, and human milk. So the percentage we can find out. The PFA standards for different classes and designations of milk in India. So the class of milk you tell me and I can tell you milk fat and MSNF value. For example, cow milk has 4 milk fat and 8.5 MSNF value. Mixed, then you have different classes of milk like cow milk, mixed milk, standardized milk, recombined milk, toned milk, double toned milk, skimmed milk, and full cream milk. Milk fats, milk fat or butter is of great economical and nutritive value. The flavor of milk is due to milk fat. It enters in milk in the form of minute globules in the true emulsion of oil in water type. Milk fat is mixture of several different glycerides. They contain about 84 different fatty acids ranging from 4 to 26 carbon atoms. Other lipid materials present in milk are phospholipids, sterols, carotenoids, and fat-soluble vitamins. Together, they constitute 1% of total lipid material. Milk proteins. Milk normally contain 0.5% nitrogen, of which 95% constitute milk protein and 5% non-protein nitrogen. Casein constitutes 80% of the total nitrogen in milk. Whole casein is a heterogeneous group of protein consisting of three principal components: alpha casein, which is 55%, beta casein 25%, gamma casein 5%, and alpha casein, which is 15%. The non-casein proteins of milk are called whey proteins. These include beta lactoglobulin, which is 60%, alpha lactobuline, serum albumin, and protease peptose fraction. What are milk sugar? Milk sugar or lactose is reducing disaccharide which on hydrolysis gives sugar, glucose and galactose. Lactose is acted upon by bacteria to produce lactic acid. Lactose occurs in two forms and when crystallized form weigh at temperature below 93.5 degrees Celsius, the hydrate of alpha lactose is formed. Ash and salts. Milk ash is a white residue remaining after incineration of milk at 600 degrees Celsius. It consists of oxides of sodium, potassium, calcium, magnesium, iron, phosphorus, and sulfur, and some chloride. In addition to this, milk contains many trace elements like copper, zinc, aluminium, molybdenum, etc. The salts of milk are phosphates, chlorides, citrates of sodium, potassium, calcium, and magnesium. It also contains enzymes. What are enzymes? Enzymes are a number of enzymes present in milk. More than 25 enzymes have been identified in cow's milk. They are distributed throughout the entire system, some bound to the fat globule surface, some associated with the casein micelle. Alkaline phosphate, lipase, xanthine oxidase are some of the important enzymes. Vitamins are also present in milk. Milk is a good source of water-soluble and fat-soluble vitamins. Vitamin K, vitamin A are present in good quantity in milk. Milk is also rich in riboflavin, but this vitamin is lost rapidly on exposure to light. Concentration of niacin and ascorbic acid is relatively low in milk. But what is the nutritional importance of milk? Milk contains all nutrients in a nearly balanced proportion to meet demands of human nutrition. It is rich in high quality protein, calcium, phosphorus, riboflavin, and other B vitamins. The calcium and phosphorus of milk are well utilized in the body. Milk it is a poor source of vitamin D, vitamin C, and iron. Milk proteins are one of the highest quality proteins and equal the meat proteins in nutritional efficiency. Milk proteins are rich in lysine. The fat-soluble vitamins of milk are quite stable to heat and processing. However, vitamin A and E are destroyed in significant amounts in the presence of oxidizing agents. Nearly 50% of thiamine is lost with heating. Let us see now different types of milk. First we have fat-free or skimmed milk. It may not contain more than 0.5% milk fat by weight. It has about half the calories of whole milk. Next milk is organic milk. It is produced by dairy farmers that use only organic fertilizers and organic pesticides, and their cows are not given supplementary hormones. The nutrient content of the milk is same as the standard milk. How do we do analysis of lactose? It is done by Lane-Enon method. It is based on determination of the volume of a test solution required to reduce completely a known volume of alkaline copper reagent. The endpoint is indicated by use of of an internal indicator methylene blue. The dye is reduced to methylene white by a slight excess of reducing sugar over that necessary to reduce all the copper. However, since methylene white is rapidly oxidized back to methylene blue or air, it is necessary to exclude air. It is accomplished by performing the titration while the solution being analyzed in boiling. Diluted sample of milk is treated with copper sulfate, pentahydrate solution and sodium hydroxide. Alkali added should be sufficient to precipitate completely the copper as hydroxide. The solution is filtered and the filtrate is transferred in a burette. Mixed Fehling reagent is taken in a conical flask and is placed on a wire gauze and is heated to boiling. It is rapidly titrated against sugar solution filled in a burette till the dye gets reduced. Let us now talk about another food material, honey. Honey is produced by honeybees from the nectar of flowers and stored in the comb. The flavor of honey depends upon the nectar. Honey is extracted from the comb, strained and marketed. Honey contains large quantities Honey contains large quantities of fructose, about 38%, then glucose, which is 31%. Sucrose constitutes about 2% of total sugar content. Honey has the capacity to retain water. Dietase and invertase are the important enzymes present in honey. Dietase is the enzyme responsible for converting starch to dextrins and sugars. Invertase is primarily responsible for converting sucrose in nectar to glucose and fructose. Raw honey contains an enzyme called glucose oxidase, which produces hydrogen peroxide, a mild antiseptic when combined with water. Honey is said to improve food assimilation and useful for chronic and effective intestinal problems. Honey also has medicinal value. The composition of honey varies depending upon its ripeness. Means how old is honey, how new is honey, its composition varies. So the moisture contained, the sucrose contained, fructose contained, glucose, reducing sausage, pH and total acidity depends on whether it is unripened or ripened. So the values are given in literature. Let us now study the analysis of reducing sugars in honey. For analysis of reducing sugar in honey, we have again Colles ferricyanide method or by Lane-Ion method as we have used for determination of lactose in milk. The next thing which we are going to study after honey is tea. Tea is made from Semillina sinensis, which is an evergreen shrub or tree which grows wild from India to China. Tea leaves are usually plucked by hand. The average interval between plucking is about a week. In India, about 5 to 6 pluckings are made in a season. Commercial tea is available mainly in three forms: black tea, green tea, and oolong tea. The three forms differ only in the matter of processing the leaves. Black tea is by far the most popular among the three, which we use in our kitchens. Black tea. The various processing steps in the manufacture of black tea are withering, rolling, fermentation, drying, grading, and packing. Withering is carried out by spreading tea leaves thinly on shelves and to dry the leaves partially. Generally, withering is allowed till water content in the leaf is lowered by about 40%. The withered leaves are then rolled to break the cells and release juices and enzymes. After rolling, the leaves are shifted and spread out thinly on suitable platforms and allowed to ferment for 2 to 6 hours at temperature between 21 degrees Celsius to 27 degrees Celsius. During this process, the enzymes bring about the oxidation of various polyphenols present in the juices, resulting in the change of color from green to reddish copper. Two of the important polyphenols that undergo oxidative changes are catechin and gallocatechin. When the fermentation has proceeded to the desired degree, further change is arrested by drying or firing. This comprises the passing of the fermented leaves through a chamber in which hot air is circulating. At the entrance of the chamber, the temperature is 93 degrees Celsius, which drops to about 49 degrees Celsius near the exit. Firing causes some caramelization to occur, resulting in characteristic color of black tea leaves. Next type of tea which we know is green tea. It is made in the same manner as black tea, but withering and fermentation steps are omitted. The leaves are heated, are heat treated, rolled, and dried. The heat treatment consists of pan firing or steaming to inactivate the enzymes. The aroma, flavor, and green color of tea are significantly different from those of black tea. Let us now see the composition of tea. The important constituents of tea contributing to the flavor of tea beverage are caffeine, polyphenols, and essential oils. Analysis of fresh leaves of Indian tea gave the following values in percent. Polyphenols is 22.2%, protein 4.3%, crude fibers 27%, starch 0.5%, and ash 5.6%. Fresh tea leaf also contain carotenes, beta vitamins, and ascorbic acid. Maximum amount of caffeine is present in the bud and in the first two leaves. Tea leaves contain a volatile oil consisting of alcohols, aldehydes, phenols, and some fatty acids. Tea does not have nutritive value. Let us now see analysis of tannin. This is one of the very important steps when we are dealing with tea. Tannin is determined by Lorentz-Proctor method, in which its oxidizability is determined by potassium permanganate. Tea leaves are boiled with water for 30 minutes and the solution is filtered after cooling. To the filtrate is added the indigo carmine solution and it is titrated against KMnO4 till the color changes to bright yellow or faint pink. Milliliters of KMnO4 used is equal to A. Simultaneously, another aliquot of tea solution is treated with gelatin solution and powdered kaolin and is shaken in a stoppered bottle. The mixture is allowed to settle and then filtered. It is then treated with indigo carmine solution and titrated with KMnO4 solution. Volume of KMnO4 solution required is subtracted from A. This gives the quantity of KMnO4 solution required to oxidize tannin. This is all about tea. Let us now move on for coffee. There are many species of coffee, but three species are of commercial importance. Coffee Arabica, which supplies the largest and best quality of coffee beans. Coffee Robusta, which yields beans of lower quantity. And coffee Liberica, whose beans are of still lower quality. The constituents of coffee that are important in making a good beverage are the flavor substances, the bitter substances, and caffeine, which is responsible for the stimulating effect of the drink. Caffeine is present in the coffee bean in both the free and combined states. Its content in the bean varies in different species. C. Arabica contains 1 to 2, C. Robusta contains 1.5 to 2.5, and C. Liberica contains 1.4 to 1.6%. Caffeine, in addition to stimulation, also contributes to the bitterness of the coffee. So we have in literature the amount of moisture, protein, fat, sugar, dextrose, ash, caffeine, and chlorogenic acid in C. Arabica and C. Arabica roasted and C. Arabica green. So even if the name is same, the the green one and the roasted one will have different composition with respect to whatever things I said like protein, moisture, fat, sugar, etc. Several organic acids are present in the aqueous extract from green coffee beans. The predominant one being chlorogenic acid and the least predominant acetic acid. During roasting, formic and acetic acid contents are increased and chlorogenic and other acids and citric and malic acids are partially destroyed. Polyphenolic substances, tannins present in coffee contribute to the bitterness of the coffee beverage. Let us now see the role of chicory in coffee. Chicory is a very famous compound which you have heard while when you hear coffee. Chicory, which is Chichorium intybus, is a well-known substitute for coffee, often used for blending up to 50% with the latter in liquid coffee extract. It gives a bitterness to beverages which some people find refreshing. The part of the plant used is the root, which is chopped, roasted, and ground. Let us now see estimation of caffeine in coffee. Caffeine is determined by Fendel's Sturbe method. To the ground sample, aluminium hydroxide and chloroform is added and the reaction mixture is placed for shaking in a machine for 30 minutes. It is then cooled and filtered. The solvent is then evaporated on a steam bath. The residue obtained is digested with water. The solution obtained is treated with excess of potassium permanganate solution, hydrogen peroxide, and acetic acid, and is heated on a steam bath and is then cooled and filtered. The filtrate is then extracted with chloroform. Combined chloroform extract is then evaporated to dryness. The residue is of caffeine which can be weighed. So this is all we have about food industry. Next I wanted to talk about cosmetic industries, but now since the video has become very long, I am going to stop the video here right now, and next video I'm going to talk about cosmetics. So what are the important takes up from this lecture about food is you have to remember what are the food processing and preservation methods. You should know what are the inorganic preservatives, organic preservatives. You should know what are the commonly used preservatives, which example is sodium chloride, sugar, sulfur dioxide, nitrate, nitrite, acetic acid, propionic acid, benzoic acid, parabens, epoxides, antibiotics, diethyl polycarbonate. Then you should know about what are the chemical methods. So first we studied about use of chemicals as preservatives. We saw benzoic acid in jams and jellies. We saw acetic acid in pickles. We saw lactic acid in poultry. We learned about sulfide in fruits. Then we also learned about role of pH in the preservation of food. Then we came on to physical methods like pasteurization. Pasteurization means you heat milk to a very high temperature and suddenly cool it. On doing this, the bacteria inside gets killed. After this, we went on for radiation. We learned that different radiations are put so that the microorganisms die. Then comes the irradiation process. We have seen different irradiation process. Then we saw determination of boric acid and sodium benzoate as preservatives. We studied analysis of food products. The first one we studied about milk. Then we studied the different things which are present in the milk like milk proteins, milk fats, milk sugars, ash and salts, enzymes, vitamins. Then we saw different type of milks. We studied analysis of lactose from milk. The next food component we studied was honey. Honey, as we know, do not have an expiry date, so it does not expire. It's a natural compound. Then we also studied analysis of reducing sugars in honey. The next food component which we studied was tea. There are three types of tea, mainly black tea, green tea, and the third type of tea is oolong tea. The composition of tea differs for different type of milk, for different type of teas. Polyphenols, protein, crude fiber, starch, ash, everything is different for different types. Then we studied how we do analysis of tannin in tea. Then we studied about coffee. We studied what is the role of chicory in coffee. Then we saw the composition of green and roasted C. arabica beans. We saw moisture, protein, fat, sugar, dextrose, ash, caffeine, chlorogenic acids are different for green type and for the roasted type. So just a roasting changes the composition. And then we studied caffeine in coffee. So this is all I had from my side. Thank you so much for watching this video. Please do like, share and subscribe. This video was completely dedicated for advanced learners. The basic learners may not have understood from anything from the lecture, but do not be the impression that my video series you do not understand anything from it. It is not so, because my videos are made for basic learners and the playlist is different. This video was completely dedicated to advanced learners. The advantage of basic videos, the advantage of basic videos is that you build up your foundation. Your foundation becomes very strong. Do not underestimate the importance of foundation. Unless your foundation is strong, you cannot build up a strong building. For building up a strong building, you need a strong base. A strong foundation is required, and that work we are doing by learning the basics. So you are learning the basics, you are building up your base. Another example I can give you is like a tree, a small plant you grow and then you make it a big tree. So if you want to take fruits, you do not work at the fruit, you work at the base. You work at the roots. So what do? You give it fertilizers, you give pesticides, you protect it from harm, correct? You give it water every time, every now and then. You give it nutrients to the soil so that the roots absorb and the roots become strong. If the roots are strong, they can penetrate deep inside and they can take the nutrients, and that nutrients will go to the leaves and the fruits will come out. So this strong foundation of chemistry will help you to clear all the competitive exams like CSIR NET, SET, PET, GATE, UPSC MPSC exams, then JEE, NEET. You'll also be able to crack the interviews which are going to be held just before you are selected for the job. Also, you will be able to answer the Viva questions. So if you want to clear all your doubts and queries, stay tuned to the channel. Keep watching the basic videos, share it with your friends. If you have not subscribed yet, do subscribe. Write it in the comment box what you do not understand. Any query you have, you comment. Anything you want to learn, you want to know, you just comment it out and I'm going to reply to your comment. So all the playlist is different for the basic series, and this was for advanced learners. In this video we studied all about food material. One more video I'm going to post in which we are going to talk about the cosmetics analysis. Why do we need to know about cosmetic analysis? Because cosmetic industry has a huge market outside. Food and cosmetics, they make up huge market after pharmaceutical. In fact, with pharmaceutical, food industry also has huge importance. Any food material which is prepared undergo quality control and quality assurance, where again analysts are required. So chemistry has scope not only in food industry, chemical industry, but in all the industries like cosmetics, food. These occupy the major portion of marketing. So we have food industry, we have pharmaceutical industry, cosmetics industries. Nowadays, these industries are earning maximum as compared to other industries. So in this video we spoke about food industry. Just we spoke about tea, coffee, estimation of chicory in coffee, then tannins in tea. We spoke about honey, and these are the only food materials which we study. If you want to learn these things in details, you can refer to the books which I have mentioned in the description box. In the next lecture we are going to study about cosmetics. The different cosmetics are face powder, then you have lipsticks, and all other things we are going to study, which is going to be again a very interesting topic, and this we are going to study in the next lecture, next class. So stay tuned, do subscribe the channel, share it with your friends and give it a thumbs up. Thank you so much for watching. Thank you.